Hello physics students, we are going to start out studying a little thing called kinematics, which is basically how things are moving. To describe how something is moving, the two most important pieces of information are what we call the position of the object, which is essentially where it is located, and the time that it was at that position. So you can think of the description of how anything is moving is really just describing where it is at different moments in time. We are going to start out just with the simple case of one-dimensional motion. So an object either moving forward and back, or left and right, or up and down, but not a combination of any of those things. Maybe it's useful to think of a train that is fixed on some nice flat straight track, so it can just move forward and back. And that is all. Alright, now we have a slight difference in definition between what we call distance and displacement. So distance is what you typically think of when you hear the word. Sometimes that's the case in physics, that the word matches the common usage, and sometimes not. So distance is simply how far you have gone. Displacement is how far, but it includes the additional piece of information of also in what direction. What direction? For the mathematically inclined, this distance is what we call a scalar quantity. Displacement is what we call a vector quantity. So just a couple quick examples here. If you think about your location on a number line, so here is a nice number line, maybe not all that nice, but you'll get the idea. Okay. If I ask you if there's an object, say a ball, starts here at location 3 and then moves over here to location -1. Well, the distance it traveled is 1, 2, 3, 4. We should have some units on here as well. The symbol for your location, we will use an x, just like the x-axis. And we want to know what it's measured in, so this could be feet or centimeters, but typically we're going to take meters. Alright, so we started here, we ended up going over here, and we moved 4 meters would be the distance that we traveled. Displacement, though, has this extra piece of information. To indicate the direction, you can use north and south or east or west or anything like that, but usually it's most convenient to just use positive and negative. And again, you can choose whichever side to be positive and negative, but the typical convention, as number lines and graphs go, is to have right positive and left negative. So while the distance was 4, the displacement would be -4. If I were going in the other direction, from here to here, they would both be 4. Distance can never be negative. If somebody asks you, how far did you go on your run today? You would never say, well, I went -3 miles or something like that. It's always going to be a positive quantity. And the value or the magnitude is going to match between distance and displacement as long as you never change directions. If we change directions, things get a little more complicated. So let's get rid of that ball there. Let's say we start over here. Go ahead and fill in a -4 here. And we'll go all the way over here to 3. So we'll say that's like leg 1 of our journey. And then we come back a little bit right here. And we end up, I'll call that leg 2 of my journey. We end up right here at 1 meter from the origin. Well, the distance is just adding up both of these legs, so I go from 4 to 3, so we've got 7, and then come back to this way, so that's going to be a distance of 9. So I'm going to say D equals 9 for this example, 9 meters. For displacement, we come this way, 7 again, and it's positive because we're moving to the right. Doesn't matter that we started at a negative location. And then so I went positive 7, and then I came back, so that's a -2. Displacement, the symbol we use for displacement is a delta x. Alright, so we had 7 minus 2 So this was a displacement of 5 meters, whereas our distance covered was 9. Another nice shortcut for displacement is simply to look at how far you ended up from where you started. And you could ignore everything that happened in between. So if I started here at -4 and I ended at 1, that's a distance from here to here of 5 meters, which is identical to what we get by adding up those two values. Alright, now usually we care about the time it took for us to move. So to factor time into the equation, we then have to deal with quantities of speed and velocity. Now speed is, again, what we typically think of, so this is how fast we're going. And you guessed it, velocity is not only how fast, but in what direction. So this includes direction information. Okay. Again, speed can never be negative. It's a scalar quantity. Velocity can be positive or negative depending on which direction you're going. So the equations, you could say that speed is how far you go and how long it took to get there. So we're going to use d for distance over t for time. Okay, velocity, we use a symbol v. Instead of distance, we use the displacement quantity, which can be positive or negative, also divided by time. So a lot of times, if you don't change direction, again, these will have the same magnitude, but they can have different positive or negative signs depending on which way you're going. Now, if you change direction, you don't have necessarily have the same magnitude at all. If we look at this example back here real quick, so let's say that this trip going from here and back there, let's say that that took, I don't know, 3 seconds. Oh, got to go back to my pen here. I'll get the hang of this eventually. Okay, so let's say this took 3 seconds. If we go over here, let's look at our speed picture. The distance was 9. The time was 3 seconds. So that is a speed of 3 meters per second. Here the displacement was 5. And the time was also 3 seconds, so 5/3 or 1.67 if you want to do some rounding meters per second. Okay, so the numbers don't match necessarily if we change directions. Alright, last thing we're going to look at is average speed and velocity. Okay, so basically there's two approaches that the problems you will see will take. Either it will specify that you went at a constant velocity, so your speed never changed, or it will just ask you about the average. And the reason for that is often we don't have all the information of your velocity at every point along a journey. So here's an example. Let's say that you are leaving for a trip at 2 o'clock in the afternoon, and let's say you're heading to, I don't know, Sacramento, and you get there, how long does it take? It takes a couple hours, so let's say you get there at 4 o'clock. Okay. Now, Sacramento is just about 130 miles away. Okay, now I mentioned we'd use meters most of the time, but we can use miles, and here we're going to be using hours. So as long as it's any length over any time, then you can calculate speeds or velocities. You just need to make sure and label it accordingly. So if I know I left at 2 and arrived at 4, and I know I went that far, if I asked you, well, how fast were you going at 3:15? Well, you wouldn't really be able to tell me because you don't have that much information. All you have is essentially the endpoints of the journey, the starting and ending location and the starting and ending times. So you wouldn't be able to tell me the speed or velocity at any specific time, but you could tell me the average. And we use the same equation distance over time, and we have a bar over the s when we're talking about averages, right? So our other equations here, these are valid only if we're assuming that, or we're told that it's constant velocity. This, if we're just talking about the average, we don't have to assume constant velocity. We can understand that it might be changing, and we're just finding what the average is. Alright, so that distance here was 130 miles, and the time from 2 to 4 obviously is 2 hours, so we end up with 65 miles per hour, or mph if you like. Okay, now the average velocity is a v with a bar over it, and that would be displacement over time. In this case, we didn't change directions, or if we did, we don't know anything about that information, so we would still have the same average velocity as long as we took heading west as the positive direction, right? So we could have possibly negative 65 miles per hour for the average velocity. Alright, that's it for this time.